Hi and welcome back. On Discord, Savi asked me how to develop an operator that combines two gradients, because blending two gradients might be very powerful to build new variations of gradients and animate them. And I thought that would be a nice opportunity to do a small tutorial on programming operators. So yes, there was a tutorial on how to combine new operators by building graphs, but sometimes it's more easier and more convenient to actually write something in C#. And this is what we are going to do in this tutorial. So I maybe first let's clean the background here. So I already created something here. Where is it? There, here. So I thought a little bit like how would you actually do this? So I prepared a little bit here, and I already started with creating this operator, this blend gradients operator that didn't exist before, by using something else like the blend vector 3. And I clicked here and I went to symbol definition and duplicate as new type. So this duplication will create a new operator. And if you write once and go to your IDE, like either it's Visual Studio Code or Visual Studio, or like I'm using Wider here, and then you can actually already search for this new operator, because it has been added to the project and it's live code. So this is what tool has been created from scratch. So all this, basically it's like the complete duplication of the, what was it, blend, I think vector 3. So you see it's identical code, but the class name changed. And so the interesting thing is a little bit, so what are we actually doing here? So I walk you through this code, and also I walk you a little bit through data types and how they're being serialized. So this is a little bit more advanced, but if you know a little bit of C# and if you're using an IDE like this one, maybe it will make things a little bit clearer. So let's start by looking at our class here. So as you can see, so right now it only does blend two vectors, which means at the bottom we normally have the inputs, and these inputs are in this case it's a mighty input slot, so it can combine any number of vector 3s, and it also has like this input of type float, which is called f, and this is only a single input. And so if we go back to our blend vector 3 here, then we see we have, let's create and vectors float to vector 3. And then if we connect this here, we see that this is actually a mighty input. So you can change the order and place like any number of values in there. And then there's a main update function here, which I will cover in a second. But I first want to show you this thing here, which is an output. And so these annotations here, they're called like attributes in C#. And it annotates a little bit of what this field or this member of this class is supposed to do. And in this case, we are telling tool that this is an output and this is the ID of this output. And it's a general unique identifier. So it's a random number and it's very long, and it's like there are special methods on how to create these numbers, and like it includes things like your processor ID and time of day and all kinds of things to generate this number, random number, to make sure that it's really unique and that there are no collisions. And so we do this so that we can rename these methods without losing the connections between them. So we never use names for connecting stuff, but we always use this unique identifiers here. And then we have the constructor. So it's a method, but it doesn't have a return value. This means that it's the constructor. And in this constructor, we basically tell tool that since this whole class is how do you say this? It's an instance. An instance is basically like the type of operator you want to code, and it's an instance of its own type. And an instance always has like an update action, so it wants an update action, and here we tell basically that the result of this update action is being updated by this update method. So like most of the time you don't have to deal with that. It's like you duplicate an existing piece of code, and then this is all being there. And in this update action we get the evaluation context. So I think I mentioned this earlier. So this context is basically, it contains like the current time and the current lights and like the current resolution and like all kinds of things. So let's say if I have like here a layer 2D and I have like a set time operator here, or like, let's say like a time clip or something, set command time, then this new time is basically being passed along this evaluation context. And once this operator is being evaluated, we can access like all these data in the evaluation time, in the evaluation context. So, and then what this update method is actually doing is it's evaluating all its input by also calling this update method here, or the get value method. And the get value method actually only does one thing. It checks whether or not the current result of this operator is being cached. And if it's not cached, if it's dirty, then this update function is being called and it's returning the new value. So yeah, it looks a little bit convoluted, but once we actually start to write some code, it will become clearer. So one thing I also wanted to show you is, so we want to work with data types here. And yes, we don't want to blend like vector 3, like this is coming from system numerics, which means it's a built-in type. But now we want to have our own type, so we can actually use gradients, which is not covered by a system system data type. So okay, let's get started. So the first thing we want to do is we want to change this input slot here from multi-input to a single input type. And we also want to change this to gradient. And right now the gradient is red because we haven't imported this data type. And if I press Alt return, then we import this one. So we see that all our code up there is no longer valid because we have to adjust that. And of course we should rename this one and call it, I guess, like gradients. And but we can leave this one here because we want to have like a blend factor between these two gradients. Or maybe do we want that? No, I'm not sure. Because Savi was more thinking about something like blending it like in Photoshop, you know, with blend or multiply. How do you say this? You multiply two gradients, so like it always gets darker or you blend it with a blend mode like screen, it always becomes brighter. Or there might be things like we want to use apply like the color or the saturation of the second gradient to the first gradient, something like this. So we want to have like different blend modes. And so for this, it might be, we could use this for the opacity of the second gradient that we want to apply to it, something like this. For now, let's comment this one out. There's one super important thing. So if you are modifying data types or like the slot type here, like from multi-input to single input, then it's super important that you give this a new unique identifier, because right now we might have somewhere in the project, we might have a connection already that connects, that tries to connect to this input. And so tool then would think, oh, wait a second, like this input, it looks like it should go to like a vector 3 because it was earlier a multi-input vector 3. And then tool doesn't like this and is likely to crash. So I have like a macro here that I can press on my rider, which is Control G, and it will generate like a new random ID, random numbers all the way. So it might be good enough also to go in there and change a couple of values here to create a new random ID, but yeah, I prefer like the proper generate random method. And then let's create a new input here. Let's give this a new unique identifier, and let's make this an input type of an int, and let's call this a blend mode. And maybe also, I guess the output of this whole thing should not be vector 3, but a new gradient. And let's also change this one here and turn this into a slot of type gradient. So, and maybe start by fetching the blend mode, or maybe since like this changing this random type is only required if you change the input type or create a new input. So maybe we start by something simple. We pick one of these two incoming gradients. Oh, wait a second, like this will not work because we want to have the single output. And we get rid of all this one here. So we get the index. Index is index get value. So we evaluate this incoming input connection if it's connected, and to evaluate it we need the time, because the input could be animated or it could be driven by some other things that is in the context, let's say beat detection or something like that. So it always needs the context. And then let's say we get like gradient 1 equals and gradients, and this of course was stupid. Let's see, we call this gradient A, gradient 1 here, and of course we must not forget to change the ID. We create another one. Let's render this properly. We create these two gradients, and then the return value is index equals 0. Then it's gradient A, otherwise it's gradient B, and this should like index, and the return value is a gradient. This is not working because can I convert from gradient to target core gradient? And then of course, like returning this input slot will not work because we want to have the current value that it's being passed in this input slot. So just like up there, we want to have get value context. Okay, and can move this one. And now if I save here, like the code is being immediately compiled. So let's switch to layout and we see yes, it's being compiled. It still exists, but we added some new input values here, which means now we have a new operator that demands these two inputs and the index, and I could now connect these two inputs there, and maybe to verify that it's working, we take another sample gradient, and if we stick the set this to sticky, we change the we see that yes, if it's 0, then we get the first one, and if it's 1, we get the second one. So this one is already working. So let's clean this up a little bit here. So now we want to actually blend these two gradients. So this might be a little bit harder because we have to understand what actually is a gradient. And the nice thing here is that since tool is open source, you can actually dive into there and look how things are made. So let's save this first and go back to our editor, and then let's go here and go to show definition. To be honest, I always forget like how this is being done because I always press the middle mouse button or F12. So where's the jump show definition? I can't find it. Inspect. Go to declaration or usage, F12. And there's a namespace here, T3 core data types. And I already opened this here. So these are all data types that are not built-in system data types like float or int or vector3, but these are data types that we defined because we needed them. So we have like different buffer types or like the mesh buffer or a point and all these kinds of things. So we want to understand how this works. So it's not so 160 lines of code, so it's not that complicated. And most of what this definition of this data type does is it explains tool.io how to write this to disk. So we have a write, and it creates a JSON writer, and then it basically writes this property into a JSON fragment. So let's quickly see what I mean by that. So if we save here, we should see like these gradients, and we can rename these gradients so we can test gradient. We can find them easier. If I save this and if I use total commander, and if I go to coding T3 operators types, and then we should have the dashboard here, which is the current operator, and then we can take the T3 file, open it in Notepad, and if I look for test gradient, we should find it. And then here we see precisely how this gradient is being stored. So we have the gradient, we have the interpolation type, we have the different steps, and each of these steps has a color with its respective attributes. So we don't have to deal with that. So it's like all like boring for us. So what's interesting is what actually is a gradient. And then we see that the main attribute is that we have a step And the step has a normalized position, normalized meaning from 0 to 1. And it has a color and a unique identifier again. So we do a lot of unique identifiers because they're easier for like animating and renaming and things like that. So like unique identifiers are really nice. So and then we have I think there should be like the actual properties here. Yes, the main property here is that we have a list of steps, and basically we have one interpolation for like this whole gradient. Right now this tells me, hey, this interpolation field could be private because we are not using it. It's not implemented yet, but eventually we could. So and then the important thing here is the sample attribute, because all the things that the gradient does is it samples with a t, again like normalized value from 0 to 1, and it returns a position. And if it can't find, because it's like maybe there aren't enough steps or it's outside of its definition range, then it just returns 1, which means pure white. So okay, and this means now to blend two gradients, we actually have to blend all these steps. And of course we don't really know where these steps are, so we first have to build a list of like all steps in these two gradients, and then blend each of these. So if there's a position like the start position 0 where it has like both have a definition, then we blend these. If we find a position where only one of these has a position, we blend this definition and sample the gradient on the other side. And then we only have to figure out like how to actually blend these two colors, but it should be straightforward because we can pick this from a bunch of operators we already have. Okay, let's do some coding. So we go back to our blend gradients here, and maybe we write how do we do this? We go through we need to create a list of all it's actually a nice programming task. So if we would let's try a little bit. So we could iterate, let's say, all steps in gradient A, and then we would get like step, which doesn't really help us because then maybe this is good. So we just say that we want to have a dictionary. So a dictionary is like something like it's a data structure that combines two data types. So we can say we have or let's say, just make a color, I can make it vector 4. Or actually, let's go back to the definition here and see what we actually returning. Yeah, we returning a vector 4. And this is a vector 4 of type system numerics vector 4. So like this is a kind of a bummer. So we have two ways of storing vectors. So one is in system numerics vector 4, which is like the built-in vector type for C# or .NET. And then we also have another vector 4, which comes with sharpdx, which eventually we might replace with another version of the DirectX wrapper. But this is like yeah, it's quite unfortunate. So you always have to make sure that you are including the right thing. So, but this should work fine. So, and we call this one our steps. New, not directory, dictionary, new dictionary. So, and so since we want to reuse this for later, so it's always like a good idea to have like this data structures as a member field. So this is a little bit, so if this would be on this is being evaluated potentially on every single frame, which means on every single frame we would create a new dictionary and then remove it because it's only a temporary variable, and this might lead to something called garbage collection, which is like resources intensive because once in a while this garbage has to be cleaned up, and this costs, that might trigger frame drops. So we don't want to have any allocations within a loop or within like a frequently called method, like this update method here. And if this is a member field, then this dictionary, we can clean it. We have to now clear it every time, steps from clear, before we actually do this. But this clear method, it will keep the data structure intact in memory and only claim that it's empty. But the data, the memory will still be there and will be allocated. And every time this dictionary is not large enough, it will extend, it will create a new dictionary with twice the size and copy the data in there. So eventually this dictionary should be large enough. And to avoid the initial copy, we can say like, let's make it like 20 entries by default, which should be plenty for most of gradients we have. So it will never have to recopy it somewhere else. So, and then we go in here and then we basically take a step and then we, this step is, in steps we add a new thing at this, so I'm thinking about floating point rounding, but I guess it should be good enough because the sample structure will, sampling of the gradients will help us with. So what I'm trying to think through is, so if we have, let's say, let's make a sketch here. Let's say this is our gradient here. And we have like, this is gradient A. And this is gradient B. And let's say we have one step at the beginning, so which is 0. And we have another thing here, which is almost at the beginning. Maybe it's 0, something like this. It's like a super small value. Then for the dictionary, these are two still like, you know, these are two different values, obviously. So I thought like maybe we should find a way to actually unify this and make sure that with some resolution it will always be the same, like rounding it to a certain precision. But this wouldn't be a problem because we can just use the sample method of this other operator, other gradient, to get a color that will pick the color on that position, and it should be good enough. So I don't think it will make much of a difference. Like the only thing that we add new steps there is that maybe we add like too many unnecessary steps. So I think it will be fine. It should be fine. So okay, so we add a step and we add the step position, the normalized position, and we add the step point color. So, and a second, take the color. We get the color. But for the, this is color A. But for the other gradient, we have to sample this color. Color B is the point. Step gradient B, sample, and we then take the step and we take the normalized position. Yeah. And maybe introduce a new variable here, replace this. Here's step A, position, or let's make it position A. So, and then we have to blend these two colors. So let's say we just, to start with, we just mix them. That should be the easiest. So we say that blended color equals vector 2 mix. Does it have a mix? A lerp? It has a lerp. We use color A and color B, and we blend white smack in the middle. And we want to have vector 4 to lerp. And this should go into the blended color. And now that I think about this, this was this data structure is kind of stupid because so like normalized position and this color is almost the definition, or it's precisely the definition of what actually a step is. So we can just use this. We say that we have a list of, or is this not required? Maybe let's get it running first and then we can optimize it. So we do this for gradient A and we do the same for gradient B. So B sample overall steps. We this is, let's call this step B, let's call this step A. We position this, then we get a color. The color is like, now we sample the other side. And then we blend again, and we add this again to our dictionary. And now you want to make sure that the gradients, the positions always need to be sorted. So we create a new gradient. Side new gradient, and we want to initialize it. And we initialize it with the steps equals a new list of steps, and interpolation type is interpolations, and it will be used in linear interpolation because it's the only thing we have. Let's create a new variable for this to initialize it. So, and now we have to fill this list. So we can do this by we have to sort by the keys. positions equals steps point keys point order by can I sort? How do I sort like a this would be quite embarrassing. So like maybe the first has to, this is only an enumerator, so we have to turn it to maybe to an array. In this array we have to order by do this. Oh. Can't remember how to do this. Function signature. Okay, if in doubt, then stack overflow, or maybe sort C# array. Oh, there's a sort. We can float array. Float array. Okay, there's an error sort. Array sort. This is more complicated than I thought it would be. Oh no, not Unity. In arrays. This sounds more realistic. So we have this position. This is already an array, and then we sort array sort positions. Okay, and then we iterate over this and create a new list. For each var p in position, and then I guess we also create a new steps. So we have the position here, position point length. So this is our result that we later want to use to initialize the gradient. And then for each p in positions, steps in equals constructor. No. So we have to create a new step, and the color is this, and the ID is new ID, and position is the position. So we can convert to 4, and this index. This is the index. Oh, wait a second, we have the index over there already. Okay. So now we created a list of these new steps for the gradient, and we assigned them to the gradient, and then we have a result here, and this result is actually this one here. So it's, I guess there must be much smarter ways to do this, but right now we should always try to find something that works and then see if it's actually doing what we think it should be doing. So there's yeah, if you are wondering, oh, this is very super inefficient, and shouldn't we cache like all these values? So you don't need that to do that, because this update value is only being called if one of these 3 inputs that you defined here is actually dirty. So which means that if you're only having like a bunch of gradients and you tweak them manually, the only time this method will be called is if we actually change something. So only if you have like animating things or something like that, then this will be called every frame. So so let's save this and see what happens. Oh, it crashed. This is not good. It crashed because again. So we get an exception here because it's pretty clear that an argument of this with this thing had already been added, which is obviously correct. So you're not supposed to use this method, but we can, I think, just use this accessor here to add something there, and then this will just replace it. So let's try this again. An argument out of range exception. Boy, this is, I guess, because we have the position from length, we get the step index. Of course, if we we need to first initialize this list, because we can't write to an index. So this is a list, but this is not like this, only like the pre-initialized list. So let's make it, since this is being sorted, we can just say steps. Let's just add a new step here. And this is also nice, because if we add there, we don't need a step index again, so we can change this back to a for loop, to a for each loop. Okay, let's try this again. So simple gradients, and it seems to work. So if we blend this here, then we can change this gradient, and we see a mixture of these two colors. So if I change this to transparent, we see it's getting a little bit transparent there. So how do we So one more thing. So right now we are blending, like we are mixing these tools, which is not necessarily what you want. So you want to have like different blend modes, like the normal blend or the multiply and stuff like that. So one really nice feature that we added a while ago is enumerations for enumerations. Let's create an emo. It's easier to explain what it is while showing it. So we have, let's say we have a bunch of blend modes we want to support. And of course, yes, this should be an enum. Let's say we have like the normal blending. Then we have like add, multiply, screen, add, and maybe like a color. Yeah, so maybe this should be good enough. And then we want to use this for our blend mode here. And there's a really nice function called it's called a map type here. And type of, we're using our blend modes. And what this does is, now if I'm saving again and going back to our blend gradients, then we see that index is no longer an index, but it's actually like this list we just created, which makes it really handy to actually work with proper defined things in code. Of course, this is now like it's no longer an index, but it's a blend mode. But since we are using these unified identifiers here, we can just rename this to blend mode. And yeah, everything should work. So we save this here. The blend mode is now called blend mode, and yeah, here we have our blend modes. And then implementing these blend modes should be easy, I guess, because the only thing we have to replace is like this mix function here. And so we rename this here to blend mode. And then we create a local method here, private vector for is the result, blend colors, and we create a color A, or maybe just A vector for B, and then we have a proper blend mode. And we return, but we can maybe say we start by, let's say, mixing, could also be a blend mode here. And so a really nice feature of this, and then of course we want to return that. One nice feature of this IDE is that you can do things like switch blend mode, and then we can say generate switch labels, which is what we basically want. So we want to have a bunch of like different switch cases here for the different blend things, and we start by taking this one here. We don't need a break statement because we are returning. We don't need this one here. Maybe boo. Okay. Let's say we return by default a white color because we didn't implement all these things here. So, but this we don't need. And now we have to think about how to mix with how to do color blending. To be honest, I don't really know how to do this, but this should be straightforward. We return A plus B. And maybe, since this could lead to alpha opacity values bigger than 1, so this is tricky. So we should never have like alpha values bigger than 1, because this will lead to super ugly artifacts that are hard to spot. So let's create a block here and let's say equals A plus B, and then by W is clamp utils clamp 0 to 1 to W, and this should be an uppercase, and then we return R, of course. And I guess we do the same with forest green. To be honest, I don't know what the blend mode forest green is. We will look this up. But for multiply, there should be multiplication. And also for the normal blend mode, we also have to look this up. So these are, I'm having a very hard time to remember like these blend formulas. So let's see if we can actually switch between a bunch of blend modes now. So normal doesn't change, screen doesn't change, art doesn't change. Oh, it doesn't change because we're not calling this method yet. So we go in here, and instead of mixing it here, we say blend colors, color A, color B, blend mode. So not there. And now if you're wondering, so this doesn't work because right now we are still getting so this is right now an integer, because back down here, like the input is of type integer, and we are only internally using it as an enumeration for the UI, for the user interface. But internally it's still an integer, but we can just cast it. So we use blend modes here. And now this should work. So now we see if we're adding these two, it's white. If we use multiply, so now we could, I think we could do things like going from a white gradient to, like, let's say we have a gradient over there, then we can change the, oh, it doesn't really work like expected. It's interesting that I can actually edit this This is kind of interesting. So it shouldn't be editable. Yeah, this is unfortunate. Maybe it's good. But we are multiplying it here. We don't want to. So we are blending the color, but not the value. Oh, this is unfortunate. Like the min max is at the end. Of course, which is totally valid. Okay, so now we can have one operator there, and we can blend its opacity with another gradient.